A 75 kVA 480 to 208 volt dry-type transformer can be installed in a boiler room if all national electrical code clearances and ventilation requirements are fully met. The National Electrical Code, or NEC, provides specific guidelines for transformer installations to ensure safety and prevent fire hazards. Two key sections to consider are 450.21 and 450.23. Section 450.21 addresses the requirements for dry-type transformers installed indoors. This section is crucial because it outlines specific conditions under which these transformers can be safely installed. Firstly, compliance with all clearance requirements is paramount. Adequate clearance around the transformer is essential for several reasons. 1. It allows for sufficient airflow to cool the transformer, preventing overheating. 2. It provides enough space for maintenance and inspections. 3. It ensures that flammable materials are kept at a safe distance from the transformer's heat. The specific clearance distances depend on the transformer's voltage and its installation location, but generally, you need to provide at least a 3-foot clearance from the transformer enclosure to any combustible materials. This clearance helps to minimize the risk of fire in case of a fault or overheating. Secondly, adequate ventilation is required. Transformers generate heat during operation due to core and winding losses. If this heat is not properly dissipated, the transformer's temperature can rise, leading to reduced efficiency, insulation breakdown, and potentially a fire. Therefore, proper ventilation is critical. The ventilation requirements typically involve providing sufficient openings for cool air to enter and hot air to exit the room. The amount of ventilation needed depends on the transformer's kVA rating and the ambient temperature of the room. You may need to install fans or other mechanical ventilation systems to ensure adequate airflow. The NEC specifies the minimum ventilation requirements based on the transformer's kVA rating. The ventilation must be sufficient to keep the transformer's operating temperature within its rated limits, typically around 40 degrees Celsius average ambient temperature, or as specified by the manufacturer. Now let's consider section 450.23, which deals with the ventilation of transformers in general. This section reinforces the importance of adequate ventilation and provides additional guidelines. One key aspect is the consideration of ambient temperature. The NEC requires that the transformer's installation environment should not exceed its rated ambient temperature. If the ambient temperature is expected to exceed the transformer's rating, additional cooling measures, such as forced air cooling, should be implemented. 2. The type of ventilation required depends on the transformer's design and installation. Some transformers are designed for natural ventilation, relying on convection currents to dissipate heat. Others require forced ventilation using fans or blowers to circulate air. The NEC provides guidelines for determining the appropriate type of ventilation based on the transformer's characteristics. 3. Proper maintenance of ventilation systems is essential. Ventilation openings should be kept clear of obstructions, and fans or blowers should be regularly inspected and maintained. Dust and debris can accumulate in ventilation systems, reducing their efficiency and potentially leading to overheating. Regularly cleaning and maintaining these systems ensures they operate effectively. In summary, to legally install a 75 kVA 480 to 208 volt dry transformer in a boiler room, you must adhere to the following steps. Firstly, verify compliance with NEC section 450.21 for indoor dry-type transformers. Ensure that all clearance requirements are met, providing at least a 3-foot clearance from the transformer enclosure to any combustible materials. Secondly, ensure that adequate ventilation is provided, either through natural or forced air cooling, to maintain the transformer's operating temperature within its rated limits. Refer to NEC section 450.23 for additional ventilation guidelines. Thirdly, consider the ambient temperature of the boiler room and implement additional cooling measures if necessary to prevent overheating. Fourthly, regularly inspect and maintain ventilation systems to ensure they operate effectively. This includes cleaning ventilation openings and servicing fans or blowers. Fifthly, consult the transformer manufacturer's specifications for specific installation and ventilation requirements. The manufacturer's instructions often provide detailed guidance tailored to the specific transformer model. Sixthly, obtain necessary permits and inspections from local electrical authorities. Before installing the transformer, ensure that you have obtained all required permits and that the installation will be inspected by qualified electrical inspectors. This helps to ensure compliance with all applicable codes and regulations. Seventhly, use appropriately sized conductors and overcurrent protection devices. The transformer's primary and secondary conductors must be sized according to its kVA rating and the applicable ampacity tables in the NEC. Overcurrent protection devices, such as fuses or circuit breakers, must be installed to protect the transformer from overloads and short circuits. Eighthly, ensure proper grounding of the transformer and its enclosure. Grounding is essential for safety and helps to prevent electrical shock hazards. The transformer's grounding system must comply with the requirements of NEC Article 250. Ninthly, label the transformer and its associated equipment clearly. Proper labeling helps to identify the transformer and its voltage ratings, as well as any associated disconnect switches or overcurrent protection devices. This is important for safety and maintenance purposes. Tenthly, document all aspects of the installation, including clearances, ventilation, conductor sizes, and overcurrent protection. Maintaining detailed records of the installation can be helpful for future maintenance and inspections. Let's delve into some additional considerations for installing a dry-type transformer in a boiler room. Firstly, the environment within the boiler room can be harsh. Boiler rooms often have elevated temperatures, humidity, and dust levels, so it's essential to select a transformer that is rated for these conditions. Consider using a transformer with a higher insulation class or a specially designed enclosure to protect it from environmental factors. Secondly, vibration can be a concern in boiler rooms due to the operation of boilers and other equipment. Ensure that the transformer is securely mounted to minimize vibration, which can damage the transformer over time. Use vibration dampening materials if necessary. Thirdly, noise can be a significant issue with transformers, especially larger units. Consider installing the transformer in a location where noise will not be a disturbance, or use sound dampening materials to reduce noise levels. Fourthly, accessibility is important for maintenance and repairs. Ensure that the transformer is located in an area where it can be easily accessed for routine inspections, cleaning, and repairs. Avoid placing the transformer in a confined space or behind obstructions. Fifthly, future expansion should be considered when planning the installation. If there is a possibility that the electrical load in the boiler room will increase in the future, consider installing a larger transformer or providing space for an additional transformer. Sixthly, energy efficiency is an important consideration. Select a transformer with a high efficiency rating to minimize energy losses and reduce operating costs. High efficiency transformers can save a significant amount of energy over their lifespan. Seventhly, safety interlocks can be installed to automatically shut down the transformer in the event of a problem, such as overheating or ground fault. Safety interlocks can help to prevent damage to the transformer and protect personnel. Eighthly, surge protection devices can be installed to protect the transformer from voltage surges caused by lightning or other electrical disturbances. Surge protection is especially important in areas with frequent lightning activity. Ninthly, regular inspections should be conducted to identify any potential problems before they become serious. Inspections should include checking for loose connections, damaged insulation, and overheating. Tenthly, proper training should be provided to personnel who will be working on or near the transformer. Training should cover the safe operation and maintenance of the transformer, as well as the procedures for responding to emergencies. Now let's discuss the specifics of NEC Section 450.21 in more detail. This section outlines the requirements for dry-type transformers installed indoors and emphasizes the importance of proper clearances and ventilation. The clearances specified in NEC 450.21 are designed to prevent the spread of fire and to provide adequate space for maintenance and inspection. The exact clearance distances depend on the voltage of the transformer and the type of construction of the surrounding walls. For example, if the transformer is installed in a room with non-combustible walls, the clearance requirements may be less stringent than if the walls are combustible. The NEC also specifies requirements for the installation of fire barriers around transformers. Fire barriers are designed to contain a fire within the transformer enclosure and prevent it from spreading to other parts of the building. The type of fire barrier required depends on the size of the transformer and the occupancy of the building. The ventilation requirements in NEC 450.21 are designed to prevent the transformer from overheating. The amount of ventilation required depends on the kVA rating of the transformer and the ambient temperature of the room. The NEC provides formulas for calculating the minimum ventilation requirements. The ventilation system must be designed to provide an adequate supply of cool air to the transformer and to exhaust hot air away from the transformer. The ventilation system should also be designed to prevent the entry of dust and other contaminants, which can reduce the efficiency of the transformer. In addition to the requirements for clearances and ventilation, NEC 450.21 also includes requirements for the installation of overcurrent protection devices. Overcurrent protection devices, such as fuses or circuit breakers, are designed to protect the transformer from overloads and short circuits. The size of the overcurrent protection devices must be carefully selected to protect the transformer without causing nuisance tripping. Now let's consider NEC section 450.23 in greater detail. This section addresses the ventilation of transformers in general and provides additional guidelines for ensuring adequate cooling. One of the key considerations in NEC 450.23 is the ambient temperature. The NEC requires that the transformer's installation environment should not exceed its rated ambient temperature. If the ambient temperature is expected to exceed the transformer's rating, additional cooling measures such as forced air cooling should be implemented. The NEC also specifies requirements for the type of ventilation system used. The type of ventilation system required depends on the transformer's design and installation. Some transformers are designed for natural ventilation, relying on convection currents to dissipate heat. Others require forced ventilation, using fans or blowers to circulate air. The NEC provides guidelines for determining the appropriate type of ventilation system based on the transformer's characteristics. Proper maintenance of ventilation systems is essential for ensuring their effective operation. Ventilation openings should be kept clear of obstructions, and fans or blowers should be regularly inspected and maintained. Dust and debris can accumulate in ventilation systems, reducing their efficiency and potentially leading to overheating. Regularly cleaning and maintaining these systems ensures they operate effectively. Now let's talk about practical aspects of ensuring compliance with these NEC requirements. Firstly, consult with a qualified electrical engineer or contractor. They can assess the specific conditions in the boiler room and recommend the appropriate transformer size, clearances, and ventilation system. A professional can ensure that the installation meets all applicable codes and regulations. Secondly, conduct a thorough site survey. Before installing the transformer, carefully survey the boiler room to identify any potential hazards or obstacles. This includes checking for combustible materials, obstructions to airflow, and potential sources of vibration or noise. Thirdly, create a detailed installation plan. Develop a comprehensive plan that outlines all aspects of the installation, including the location of the transformer, the clearances required, the ventilation system design, and the grounding and overcurrent protection schemes. Fourthly, use high-quality materials and equipment. Ensure that all materials and equipment used in the installation meet or exceed the requirements of the NEC and other applicable standards. This includes the transformer itself, as well as the conductors, conduits, and overcurrent protection devices. Fifthly, follow the manufacturer's instructions carefully. The transformer manufacturer's instructions often provide detailed guidance on installation, operation, and maintenance. Follow these instructions closely to ensure that the transformer is installed correctly and operates safely. Sixthly, perform thorough testing and commissioning. After the installation is complete, perform thorough testing and commissioning to verify that the transformer is operating correctly and that all safety systems are functioning properly. This includes testing the insulation resistance, the winding resistance, and the overcurrent protection devices. Seventhly, document all aspects of the installation. Maintain detailed records of all aspects of the installation, including the transformer size, clearances, ventilation system design, grounding and overcurrent protection schemes, and testing and commissioning results. These records can be helpful for future maintenance and inspections. Eighthly, train personnel on safe operating procedures. Provide training to all personnel who will be working on or near the transformer. The training should cover the safe operating procedures for the transformer, as well as the procedures for responding to emergencies. Ninthly, establish a regular maintenance program. Develop a regular maintenance program for the transformer and its associated equipment. The maintenance program should include regular inspections, cleaning, and testing. Tenthly, stay up to date on the latest codes and standards. The NEC and other applicable codes and standards are constantly evolving. Stay up to date on the latest requirements to ensure that your installation remains compliant. Finally, consider the impact of the transformer installation on the overall electrical system. The installation of a new transformer can affect the voltage regulation, power quality, and protection coordination of the electrical system. Consult with a qualified electrical engineer or contractor to ensure that the transformer is properly integrated into the existing electrical system. Now let's delve into specific examples related to clearance and ventilation. For example, let's assume you're installing the 75 kVA transformer in a boiler room with concrete block walls. In this case, the clearance requirements may be less stringent than if the walls were made of wood. However, you would still need to maintain a minimum clearance of at least 3 feet from the transformer enclosure to any combustible material stored in the room, such as cardboard boxes or flammable liquids. For ventilation, let's say the boiler room has a high ambient temperature, typically reaching 90 degrees Fahrenheit during the summer months. In this case, you would need to provide additional ventilation to ensure that the transformer's operating temperature remains within its rated limits. This could involve installing a fan to circulate air or adding additional ventilation openings to the room. You would also need to consider the transformer's location within the boiler room. Avoid placing the transformer in a corner or near other heat-generating equipment, as this could further increase its operating temperature. Instead, try to locate the transformer in a well-ventilated area where it can receive a constant supply of cool air. Another important consideration is the type of enclosure used for the transformer. If the transformer is located in a dusty or corrosive environment, you may need to use a special enclosure that is designed to protect the transformer from these conditions. For example, you could use a NEMA 4 enclosure, which is designed to be watertight and dust-tight. You should also consider the potential for moisture in the boiler room. If the boiler room is prone to flooding or condensation, you may need to take additional measures to protect the transformer from moisture damage. This could involve installing a sump pump or using a dehumidifier to reduce the humidity level in the room. It's also important to ensure that the transformer is properly grounded. Grounding helps to protect personnel from electrical shock and to prevent damage to the transformer in the event of a fault. The grounding system should comply with the requirements of NEC Article 250. In addition to the technical aspects of the installation, you should also consider the administrative requirements. This includes obtaining all necessary permits and approvals from local authorities. You may also need to coordinate with the utility company to ensure that the transformer is properly connected to the electrical grid. The installation of a 75 kVA 480 to 208 volt dry transformer in a boiler room requires careful planning and attention to detail. By following the requirements of the NEC and consulting with qualified professionals, you can ensure that the installation is safe, reliable, and code compliant. Remember to prioritize safety throughout the entire process, from planning to installation to maintenance.